This example will show you how to do binomial distribution problems in Microsoft Excel. So think about the binomial distribution is you have to be able to tell that problem is a binomial distribution problem. So let's take a look at this example. Let's say you have a dice. And then we're going to define x as the number of times that face 6 turns and 10 tosses. So we're going to throw the dice 10 times and see how many times the 6 shows up. If we toss 1 6, then that's going to make x is 1. So accordingly, the random variable is x, and then the x could be anywhere between 0 times, 1, 2, all the way up to 10 times. The outcomes are defined to be success or failure. The probability of success, which means I see a 6, is P of S. Then it's going to be 1 over 6, because there are 6 faces. And all the other times, 1 through 5, it's going to be probability of failure, so that's P of F, and that's 5 over 6. And we typically define the Q to be 1 minus P, so P in this case is a success, 1 over 6, and Q will be 5 over 6. So let's look at a couple different problems. What are the probability when P is 0, P of 1, P of 2, P of 3, and P of X less than or equal to 3, and P of X just less than 3. So we'll use Excel's binomial distribution function, binom.dist. In Excel 2007, there's no period there, but either way, the syntax is the same. And then the syntax is binomial distribution x, comma, n, comma, p, and either true or false for the cumulative part. And I'll show you what that means. So from this problem, you know that it's going to be 10 tosses. So n is 10. P will be 1 over 6. That's the success when I see a 6. And Q will be 5 over 6, as we saw up here. The x's we're going to look at are 0, 1, 2, and 3. So what are the chances that we don't see any 6's? In this case, x will be 0. B17 is n, comma, what's the p right here? And then false. It's a false because it's not cumulative. We are only looking at the single instance where x is 0. So this is going to be false if you're looking at the single instance. You might wonder what happened to the q. Well, Excel's smart enough to know that if I give Excel the p, it can internally calculate the q, so I don't have to tell Excel what the q is. So all I have to put is x and p, and cumulative either true or false. In this case, it's going to be false. Same thing for the p of 1, except that it's 1 here. Everything else is the same. Same for p of 2 and p of 3. To convert the digital or decimal to a fraction or a percentage, you can press this button up here, percentage button. You don't have to. So what about this case where x is less than or equal to 3? Well, in this case, x is still 3. P is 0.16667 still. And then it says true here. It is true because we're looking at the cases where x is less than or equal to 3. That means x could be either 0, 1, 2, or 3. So we're looking at all these cases together. So that's cumulative. That's why it's true here. How is that different from this one up here? Well, the difference between these two is that it says x is less than or equal to 3 here. So that means the cases of where it's 0, 1, 2, and 3. Whereas down here, we're not looking at the case when x is 3. X is less than 3 means cases where when the x is 0, 1, or 2. So if you don't see the equal sign underneath the less than sign, that means this number up here, it's not a 3, but it's 2. So in that case, the probability is about 77.5%. So this is how you do binomial distribution problem in Excel.